So we're going to take a look at some exponent properties today, and we've actually done a bunch of this. This is a little bit of review, but maybe just expanding what we know a little bit more as well. So we're going to take a look at this expression x to the a times x to the b. We're going to rewrite this product. So first we're going to take a look at how would we actually rewrite this product right here. Or we could say simplify this product. And we've done this before. If we multiply variables, we add the exponents, which would get us x to the sixth. So generalizing this, just like we had said, if you multiply variables, we're going to add exponents. Okay, so we're going to try a couple of these using that property. Keep in mind, if we have coefficients like we do here, we have to still multiply those as well. So 5 times 6, you get 30. And then when you multiply variables, we add exponents for 7. For this next one, when you multiply variables, you have to add exponents. Just keep in mind, it's the same variables. So I'm going to be multiplying the x's and adding those exponents, which would give me 9. Then I'm going to multiply the y's, which means I'm going to add those exponents, and that would get me 3. Okay. Next property we're going to take a look at is our division. And how can we simplify this? Again, we've done this before. When you divide your exponents, we would subtract. So we're going to rewrite this just to make sure we understand why that works in simplest forms. And it says using the properties that we did up above and the multiplication property of fractions. So I could expand x to the fifth, and I could write this as x squared times x cubed, because I know if I multiply variables, I would add your exponents to get 5. And then I would divide this by x squared. Now, when we're dividing fractions, we can reduce out both of the x squareds, leaving us with x cubed for a final answer. Now, another way we can take a look at this is if I have the 5 and the 2, I could do the same thing by saying x to the 5 minus 2, which would give me x cubed. Okay, so in general, we are going to say this: when you are dividing, you want to take your exponents and you want to think subtract. Now again, they're saying a is greater than b. It means we have a larger exponent on top, and that's going to get us our final value of x to the a minus b. So we're thinking subtract. Now, when you have coefficients, you would do what you normally would do. So for here, I would have to do 6 divided by 12. Keep in mind, that's going to reduce to 1/2. Okay? Now, when we subtract our exponents, we have 10 minus 4, which would get us 6. So I could say this is 1/2 x to the 6th. Another way that I could write this equivalent expression would be saying x to the 6th over 2, because keep in mind I could put that over 1, multiply tops with tops, bottoms with bottoms, and it would get us that. So either of these two expressions are equivalent. Okay. Over here, now again, we are going to subtract our exponents. So I have 6 minus 1. Keep in mind there's a 1 there. That would give me x to the 5th. And then I have 3 minus 2, which would give me y to the 1st. Okay, so when we are dividing our variables, we want to think subtract our exponents. Now, that was in the case of the numerator's exponent was larger than the denominator. But what if it's opposite? So we're going to start by taking a look at this like we did in our last one. And we're going to say, well, let's just expand this out. We're going to rewrite this. I'm going to rewrite this as, again, x squared times x cubed, because we know if we multiply variables, add exponents, those are equivalent. And so now I would do the same thing. I can reduce out the x squareds. So what does this leave me with? This leaves me with 1 over x cubed. Okay, so what happens if we apply that exponent property number 2 to it? What do we get? So exponent property number 2 says we would subtract. So I could say this is 2 minus 5, and if we simplify that, that gets us x to the negative 3. Which, again, if I make this connection with a variable in the denominator, if I wanted to take that out of the denominator, we know all I need to do is take that exponent and make it negative. We've done this earlier. So we can generalize this, saying if I have a negative exponent, that's really the same thing as saying 1 over x to the a. Okay. using those negative exponents, we're going to rewrite a couple of these. So again, if I have a negative exponent, I always think it puts it into the bottom of a fraction, into the denominator. So now this is 1 over 2 cubed. So once you put it into that denominator, you lose the negative. We can expand this because I know 2 cubed is going to give me 8. So this is really 1/8. Okay. For our second example over here, this is going to get me just 1 over x to the positive 4. So again, it goes into the denominator of a fraction, and once you make that move, you lose that negative sign. Okay, taking a look at another property. So what if they are the same? Okay, well, think about what we just did on the last one. If I am taking these two and I'm dividing them, we know that we could subtract our exponents. I know that if I have the same value on the numerator and the denominator when I am dividing two expressions out that are the same, I know it equals 1. Okay. If we tried to do what we did the last time, which we can, I would get 3 minus 3, and I know that that's going to get me x to the 0. But we know that anything to the 0 power is always equal to 1. So we're going to simplify each of these. Okay, so same idea. Anything to the 0 power is 1. Now be careful with this next one, because I know we look at this and think anything to the 0 power is 1. That's true. But don't forget you have the 3 in front. So anything to the 0 power is 1 times 3. This would simplify down to 3. Okay. So now we get something that's a power raised to a power, and we have always said a power raised to a power you multiply. Why does that work? Well, if I were to take this and if I were to expand this out, let's think about what this is. X squared times x squared times x squared. Okay, and now if I'm multiplying this like we've looked at earlier, we have said I can add all of these up. This is really the same thing as saying 2 plus 2 plus 2. I think that was our first property that we looked at. And so that's going to get us the value of x to the 6th. And we can also get x to the 6th by saying power to a power we multiply. So over here, we're going to just do that. A power to a power, we're going to say is the same thing as doing a times b. Okay, so if we're looking at this, which of the following is not equivalent to 30? Okay, well, if we have here a power raised to a power, I'm going to think multiply. That's going to get me x to the 30, so it's not choice 1. Same here for 2. Power to a power, I multiply. That gets me 30, so it's not choice 2. When I am multiplying variables, I want to think add exponents, so 5 plus 6. That's going to get me 11. That looks like that's our winner. Let's check 4. Okay, same thing here. Because I'm multiplying variables, I would add the exponents, and that would get me 30. So it looks like choice 3 is going to be our winner. Okay, and then we have 2 final properties to take a look at. And we are going to look at what happens when I have 2 variables raised to an exponent, whether being either multiplied or divided. So this first one, we're going to rewrite this x times y, that whole quantity cubed, using that definition of an exponent along with our associative and commutative properties of multiplication. So in other words, we're going to expand this. Okay, so I have xy times xy times xy. Now, using those associative and commutative properties of multiplication would say, well, this is really equivalent to x times x times x, and then the y's times y times y. Okay, so if I multiply variables, which I am, I know I can add exponents. So these all have exponents of 1. 1 plus 1 plus 1 would get me 3. Same thing over here. So I have x cubed, y cubed. Okay, so in general, if I have 2 variables raised to an exponent, I know I'm going to add x to that exponent and y to the exponent. Okay, so how does it change if we divide? Well, we're going to try the same thing. We're going to use that definition, do the same thing like we did. So I'm going to have x times x times x divided by y times y times y. And when you multiply variables again, add your exponents. Keep in mind these are all ones. So if I add up on the numerator, I get x cubed. If I add in the denominator, I get y cubed. And so in general, if I'm looking at this, I could say, well, it looks like both the numerator and the denominator get that exponent. So the numerator and the denominator will get that exponent. Okay, so let's see what happens here. So with this first one, keep in mind, if we were to expand this out, this would be 2x squared times 2x squared times 2x squared. I show you this because don't forget about the 2's. Those 2's, those coefficients still have to be cubed. They still have to have that exponent applied to it. So I really have 2 cubed, which gets us 8. And then remember, power to a power, I multiply 2 times 3, I get 6. And again, we can see that by adding those exponents. Over here, same idea. So I have a number, okay, a constant, 3 is still going to be squared. So 3 squared, I get 9. And then on the bottom down here, I'd have x squared squared. So power to a power, I would multiply and get x to the 4th. Again, if you want to expand this to see what's going on, perfectly fine. And if it's easier to simplify it that way, do that. Okay, which may be in the case of this. We're going to try it without simplifying, just thinking of our properties. Let's start with our coefficients first. So I have to do negative 2 cubed. So negative 2 times negative 2 is a positive 4 times negative 2 is a negative 8. Okay, and our numerator, I have a power to a power, so we would multiply. Power to a power, we multiply. Right, on the bottom, same idea. So I have 3 that needs to be cubed. 3 cubed is going to get us 27. With the z, I have a power to a power, so 3 times 3, we have to multiply that, and that would be your final answer. So this is a little bit of review, a little bit of maybe new, maybe giving you a little bit more background behind why some of those properties work. We are going to keep working with this and expanding this. Bring any questions that you have to class. Hope you guys have a great day.